Hello students, welcome back to the second lecture on vectors. In the previous lecture we have seen what a vector means and how to do the addition, subtraction and scalar multiplication among the vectors, and then we also have seen how to represent vectors in a easier way if we introduce a coordinate system, okay, and we have seen some problems based on that. And today's lecture, let us focus on first, before we go into the next topic on vectors, let us recollect what all we did, the main points, and then we go into the major focus today, which is the scalar product between two vectors. So, the vector, we have the definition is, never forget, a directed line segment. Okay. So, whenever we it is specified, and also we have seen in our discussion all the vectors are specified only by its length, and vector means, remember, when I say a directed line segment, this has two components called the magnitude and the direction. And when I say a directed line segment, for example, if I call this line segment AB, this has a length and it has the direction. It does, and also in our discussion the vectors, it does not matter where it is located. Okay, so therefore, this vector, the AB is, for example, if I take same vector parallel to this with the same length, then both the vectors are same, both are located in a different place, but it is same, both are considered as the same vectors. Okay, so AB and CD are same vectors, so we do not distinguish between the AB and the CD as long as they have the same magnitude and the same direction. And also we have seen, we have introduced something called the magnitude is defined as the length of this vector. We represent the vector by AB with a arrow mark on the top. So, this is called the magnitude or length of the vector, and it is also called the magnitude of the vector AB, the vector AB. And generally we also represent any given vector by a small letter. When I specify the direction, we write like this, for example, AB and CD are having the same directions and same length. Next, we also introduced some different types of vectors, namely equal vectors. Equal vectors means they both are having the magnitude and the directions of the vectors are equal. And also we have seen the zero vector. What I mean by zero vector is, if the length is 0, it is called a zero vector. And also we have, recall the point, if I take the vector AB, this A is called the tail of the vector and B is called the head of the vector, or you can also call it as a position, it is a starting point, I mean it is the initial point and it is a terminal point. Okay, the tail and head are the right names. And also we have seen unit vector. Unit vector, when the length is equal to 1, it is called a unit vector. So, in any vector we can always find a vector with unit length. And how we introduce the addition, we have seen, that is, if I have a vector A and we have some vector B, okay, I call this A and I call this vector B. Okay. What we do, since in our case we do not distinguish where it is located, what we do is we keep both the vectors in such a way that the tail of the second vector coincides with the head of the first vector. Okay. So, that it means, so now this also is equal to B in our, according to our assumption. So, this is the vector A and this is the vector B. And what we mean by, so that vector addition is defined according to the law known as the law of triangle. So, therefore, this, if I complete this triangle, then this vector, for example, if I denote it by the letters capital A, capital B, C, then this vector AC is nothing but the addition of this A and B. Okay. This is the sum of the two vectors. This is how the vectors are added. The same way, if I have a let me just repeat it, if I have the vector A and if I have the vector B, then if this is the A plus B we have seen, and if I complete the parallelogram, okay, if I complete this parallelogram, so this line is parallel to the vector B, okay, and this line is parallel to the vector A. I complete this, and this line, this diagonal. So, the one diagonal, the vector, if I denote the vertices by A, B, C and the new vertex D, then this already we have seen this AC is your A plus B, and the vector DB, the DB. So, AC is equal to A plus B and DB is equal to A minus B. So, this is how we introduce the we understand the addition and subtraction between the vectors. Similarly, we have seen the scalar multiplication. If I have any vector, then k times A. Suppose if I have a vector A, then the k times A is the same direction, but k times longer. Okay, k may be less than 1 or does not matter. So, k times longer. So, k, this is called the vector, new vector with the same direction, but the magnitude is changing. Okay. And next we have seen, we have introduced the, to represent in a easier way the vectors, we introduce the coordinate system. The to coordinate system, remember we take a 3-dimensional coordinate system, rectangular, right angle, rectangular coordinate system, and in the, this is the, if I call this x axis, then this will be the y axis and the z axis, and in each direction, the positive direction of the x axis, the unit vector is denoted by the symbol I, and the unit vector in the y, y axis, this is the origin O, and the unit vector in this is denoted by the j, and unit vector in this denoted by the symbol k. So, the I, j, k are the unit vectors. So, I, instead of writing this notation, simply I write the letter I. Similarly, j is a unit vector, k is a unit vector. Okay. And now if I take any point P, P let us say P is the point x, y, z, and we know that how, what is this, the x, y, z are the components of the point, generally with the understanding that if I project it on the xy plane, if I projection point is q, and then this vector, if I consider this OQ and OP, and remember this, then if I take this, then this is your x, this length O, this length is your x, okay, or let me, for to avoid the confusion, let me put the ABC, okay, ABC, ABC, then this point is A, and if I project it on the y axis, okay, so these are all making 90 degree, and now here this is the point B, and this height is the C, okay, and we have this vector, that is OP. Okay. OP vector is now if I introduce this Ij, then this automatically the B is nothing but B, this B is the length between the origin and this point. Okay. Therefore, OP is equal to AI, because this length is AI, this vector is AI here, Bj here, and C, and this is Ck. Therefore, OP is equal to AI plus Bj plus Ck. So, this vector is called, so this is called the position vector of P. Okay, this is easy to represent a vector if I know the position vectors. So, position vector of the point P. Okay. So, for any point, so I can represent the point by simply the coordinates ABC, or simply, or I can write this as a vector AI plus Bj plus Ck, and we call this AI plus Bj plus, that is this OP vector. Okay, this OP vector is called the position vector of the point P. And if I say, so with that understanding, if I have any point P and Q, for example, let us say this is the coordinate system, and if I take any 2 points A B or P Q, then I know the position vector here. Once I am given the points P and Q, then I know the position vector of P and the position vector of Q. Then automatically what we are interested is the line joining the vector joining this P and Q, okay, this PQ, okay. So, this is O, this is the way, this is what we know, this is the position vector of the point P and this is the position vector of the point Q. Therefore, the vector what we want to represent, that is PQ, is equal to simply OQ minus OP. So, this is what I wanted to remember all the time. So, PQ, the vector PQ can be represented in terms of the position vector OQ minus OP. So, position vector you are already we are familiar now, therefore, any vector can be represented in terms of the position vectors. And with this understanding, let me just give one problem now, and then we will move on to the next topic. Suppose let us take a quadrilateral. Okay. So, let me take a quadrilateral with the 4 sides, something like this, and then so let me call it ABCD, and then I draw the diagonals, that is DB and AC. Let us say that let us say P is the midpoint of the line. So, that is the point P divides this length into 2 parts. Okay. This AP is equal to, the length AP is equal to PC. Similarly, here I am, this point Q is dividing DB into 2 parts, equal parts. Therefore, now Q is the midpoint of DB. Okay. P is the midpoint of, but how to represent this P and Q I will explain next. And now for this problem, just you can just say that P and Q are the midpoints of the diagonals. So, midpoint of AC and Q is the midpoint of DB. Okay. With that understanding, now let us show that. So, this problem just will make you familiarize with the representation of vectors. Show that AB, okay, now the vector AB. Now, when I say vector AB, let me put the directions. AB, the vector AB plus vector AD, vector AB, vector AD. So, plus vector CB, anyway it does not matter. Vector CB plus vector CD is equal to 4 times the PQ, okay, PQ. AB, AB, AD, CB plus CD. Okay. So, the left hand, we have to prove that the left hand side is equal to the right hand side. So, already we know that how to represent the AB, because once I know that I can write AB as a in terms of the position vector. So, AB is equal to OB minus OA. So, let me take the left hand side, LHS OB minus OA. Similarly, AD can be written as OD minus OA, and CB can be written as OB minus OC, and CD can be written as OD minus OC. Okay. So, this now there are positive terms and negative terms, I am just grouping them together. So, therefore, it is equal to 2 and OB, if I take OB, OB occurs 2 times, therefore, 2 times OB and the other vector OD, okay. OD is also occurring twice, and then minus, if I take outside 2 and OA plus OC. Now, this is equal to OB plus OD. Okay, if I take this, if they take this is the origin, OB plus OD is equal to is equal to, so it is equal to 2 times OQ, because OB, this I will prove it later, OB, the OB plus OD by 2, if I take the average of these two vectors, it is equal to the OQ, the midpoint. Okay. How this is, let us see now. Okay. So, let us right now let us assume that OB plus OD by 2 is equal to OQ, therefore, it is simply OQ. The same way OA and OC, okay, OA and OC, if I connect, then it is a midpoint, the OP I am getting. So, 2 times OP. Okay. So, therefore, it is 4 times OQ minus OP, which is equal to 4 times PQ. So, this is what we wanted to prove. So, now the question is how to prove this part. Okay. So, for that in coordinate geometry you might have studied, if there are two points P, let me denote it by x1, this problem is over right now. Only thing we are interested in proving this part. So, let us take 2 points, say let me call P x1, y1, z1, that means we know the position vector of the point P, x1i plus y1j plus z1k. Similarly, I have another point Q, I am calling it x2, y2, z2 in the space, and we have the origin, therefore, we know the position vector OP, and OQ we know, and now I am considering this line. So, let me call this OP as R1 vector and OQ I am calling it R2 vector. Okay. Now, I am just connecting this line, this PQ. Now, I am taking one point that divides PQ into in the ratio. So, R divides, so PQ are given, be given 2 points, and let R divide PQ in the ratio L is to M. Okay. So, if I take this is the point R, then this is L and this is M. So, this LM internally R divides PQ in the ratio L is to M, and then R is given by, so let us say the coordinate of R is x, y, z. So, therefore, what I want to know is only this OR. So, I want to know what this OR is. I am calling it R vector. Okay. This now in geometry you might have studied this R is given by, the point R is given by, okay. So, the coordinates mx1 plus lx2 divided by m plus l, and my1 plus ly2 divided by m plus l, comma mz1 plus lz2 divided by m plus l. So, this is the coordinate of the point R which divides the PQ in the ratio LM. Now, OR is equal to, if I write OR in the vector form, it is equal to 1 by m plus l, I can take it out because it is common in all the components. So, m plus l, and then I am writing this vector as, and I am just combining the terms with m. So, this will be x1i plus y1j plus z1k. You can just see, so m terms I am combining, okay, and similarly, so 1 by m plus n is gone outside, and now plus next the rest of the terms with the L, that is x2i plus y2j plus z2k. and what is this? This is nothing but, if you look at this term, this is nothing but the position vector of the point P, okay, the position vector of the point P. So, therefore, this is equal to 1 by m plus L, 1 by m plus L, m into r1 vector, because already I am denoting this vector by OP by r1 vector. So, r1 vector plus L times r2 vector. Okay. Now, if m is equal to L, okay, in particular, so this is the vector. So, if I want to write, if you want to find a point which divides the point, the line PQ into the ratio L and m, then that point is given by this position vector 1 by m plus L, m times r1 and L times r2. So, that is what you have to remember. So, m times r1, L times r2. Next, so in particular, take m equal to L, that means equal ratio. So, in that case what is happening? So, OR, then R becomes the midpoint, okay, R becomes the midpoint of PQ. Therefore, R is given by, then OR is equal to, this is equal to 1 by 2, because m is equal to L. So, that can be taken out, and so therefore, there will be, so when m is equal to L, that 2 will be there in the denominator. So, it is simply R1 plus R2 divided by 2. So, the midpoint, so if any two point is given, if I know the position vector, okay, if I know the position vector, then the midpoint is given by simply the vector. So, if I call this is the origin and R1, R2, the midpoint is given by, so this is the midpoint is given by simply 1 by 2 times R1 plus R2, okay, this is Q, this is P. So, P, so this is the, so because of that, in the previous problem you might have seen I have taken OB plus OD, okay. So, OB plus OD, the midpoint is given by, the OQ is given by OB plus OD divided by 2. Okay. So, with this information, let me also recall what we did in the previous class. If I take a coordinate system, take a point, okay. So, let me call this point as P is x a b c, and this is the origin and right handed coordinate system, this is x axis, y axis, z axis. So, we know the meaning of a b c, and then I am taking, now if I project it on the xy plane, this is q, and then this point is your A. Okay, this point, let me call it capital A, and this length OA is equal to your A, we know that, right. Now, if I look at this triangle OAP, that is the OAP, and maybe let me represent this radius, this vector, the position vector OP, it makes an angle, let us say alpha with the positive direction of the x axis, okay, positive direction of the x axis, and then the same OP makes an angle beta with the positive direction of the y axis. So, let me call it beta, and let me call this. Similarly, the OP makes angle gamma with the positive direction of the z axis. Now, you just look at this triangle. So, therefore, this point is B and this point is C. Now, if you look at this triangle OBP, if you look at this triangle OBP, which is a right angle triangle and right angled at the point B, and here cos beta, which is let us say OP is a vector given, OP, the modulus of OP is equal to the magnitude we know, and cos beta, now since this is the B, so cos beta is equal to B by mod OP, adjacent side by hypotenuse. Same thing, cos gamma is equal to, from the figure I can see, cos gamma is equal to C by mod OP. Okay. And similarly, the cos alpha. So, from the figure it is little tough to see, but you can imagine, you can just verify that cos alpha is equal to A by mod OP. Now, it is customary to write this cos alpha, L is equal to cos alpha and M is equal to cos beta and N is equal to cos gamma, and it is easy to see that L square plus M square plus N square is equal to 1. Okay. And these LMN are called direction cosines of the point P. It is called direction, LMN are called direction cosines of the point P. Okay. And remember, if I because now then what is the, from the equations, A is equal to L into mod OP and B is equal to M into mod OP and C is equal to N into mod OP. These ABC are called direction ratios. ABC are called the components of the vector are called direction ratios. But remember, of the point P, only for direction cosines we have this L square plus M square plus N square is equal to 1, whereas A square plus B square plus C square is not equal to 1 in general. So, direction cosines and direction ratios, so do not get confused. If you have any point in the space, remember we know the position vector of any given point, the unit vector in this will be the unit vector in the OP is the if you look at the components are the direction cosines of that point, and any point in this are called, if I take the components of any point and this, they are called the direction. So, direction ratios are proportional to the direction cosines. Okay. So, any given point P, remember the direction cosines are simply the component, take any point, the unit vector in this, the components of the unit vector are called the direction cosines. Okay. So, never get confused with the direction cosines and the direction ratios. So, direction cosines are just normalized ones with the unit length, remember. And with this understanding, let me just for example, if I take 2, let us take one point 2 minus 1 and 2, let us say this is the point in the space 2 minus 1 2, and what will be the direction cosines. So, for that we should know what OP is. OP, the vector OP, the modulus of the vector OP is equal to square root of 4 plus, I am just squaring the components, as 1 plus 4, which is equal to 3. So, the length of that vector is 3, therefore, cos alpha. So, the unit vector is simply cos alpha, cos beta, cos gamma, the components of the unit vector. Okay. This is equal to 2 by, because 2 by 3 minus 1 by 3 is again 2 by 3. Okay. So, this vector, the unit vector, therefore, this I cos alpha plus j cos beta plus k cos gamma. Okay. Suppose if this is the point P, okay, and this is the origin OP vector, then this vector, this point, let us say, let us take, if I call u, okay. So, this OA is equal to u, then the vector OA is the vector u, then u is the vector u is simply this, I cos alpha plus j cos beta plus k cos gamma is the unit vector along OP. Okay. So, if we know the direction cosines of any given vector, then we know that what it means is we know the unit vector in that direction. Okay. And with this understanding, now let us move on to the main topic, namely the equation of a line. Okay. We are going to introduce the equation of a line and the equation of a plane, but it is easy now, for whatever we have studied, with that information we can write the equation of a line, but to write the equation of plane in an easier way, we need to introduce the product of vectors, that we will do later. Now let us we can introduce the equation of a line. To find our aim, let us do, so to find the equation of a line, what we need is, we need the direction of the line. Okay. So, suppose we want to find the equation of a line, we want to know how the line is located, and direction of that line we should know, and also because we can draw several lines parallel to that. Okay. So, the direction itself is not enough, but what we also need is, we need some point through which the line is passing through. Okay. So, if I know the point P and the direction, then we can uniquely specify the equation of a line. So, the first case, the simple case, let us take to find the equation of a line, of the line passing through the origin, O. Okay. So, let us say now instead of P, now it is given that the O is given. Okay. The line is passing through the O, and direction, assume that we know let u be the unit vector. So, if I know the direction cosines, then I know the unit vector in this direction. Let u be the unit vector in that direction. Be the unit vector. So, let me call the line as L. Okay. The line, or capital L will be better, because L should not be confused with the cos alpha. Okay. So, what we have, let me call it line L. So, unit vector along the line L. Okay. Now, the equation of the line. So, now we take any point. Okay. If I take any point, it is of the form x, y, z. Then I know the direction, I know it is passing through origin, therefore, our r is equal to, if I take the r vector, so if I call it P, my OP is equal to over r. P is the general vector, arbitrary vector, OP is equal to the vector r. Now, r is equal to, it is because I know the u vector, okay. I know the unit vector in this direction, therefore, P has to be some k times this u. Okay. So, k times u is the unit vector, therefore, r is equal to k u, where k is a scalar, So, this is the equation of any point will satisfy this. K is a scalar. For different values of k, we are getting the different. So, the locus of the point P will be the straight line. Now, let us instead of origin, let us take a general point P. So, now to find equation of L, passing through some arbitrary, some other given point, passing through a point P. Let me call the point P is given. So, now let me take this case, P is some ABC. Okay. Now, and so the point P is given. Assume that this is the origin and we know the OP, which is equal to the position vector of P, okay, position vector of P, which is equal to AI plus, this is ABC, AI plus BJ plus CK, that is the position vector of OP. Now, I am taking one arbitrary point here Q, which is equal to XYZ. Now, if I take this OQ, the position vector, OQ is nothing but XI plus YJ plus ZK. Okay. Now, so OP we know, OQ is there, then to find the equation of L passing through ABC, the R, if I take this vector as R, then R is equal to OP, this is the point P, therefore R is equal to, that is R is nothing but OQ, okay. R is equal to OP plus PQ, okay. R is equal to OP plus PQ. Therefore, now what is the OP? OP is your given vector. So, let me call that vector as, because since it is fixed vector, let me call it some D vector. Okay. So, therefore, this is D plus the PQ. What is PQ? PQ is equal to some alpha times, because I know the unit vector in this direction, alpha times U, because I know the direction, because since I know the point I can find the direction, because ABC are the direction ratios, therefore, we can always find the unit vector in that direction ABC. So, where U D plus alpha times U, where U is alpha is a scalar, where U is the unit vector, because since I know the PQ, the U is the unit vector along L. So, if I know the unit vector along the L and the point P is given, so the position vector is D, and then R is equal to, the equation of the line will be D plus alpha U, where U is the unit vector along the L. And the more general case is the last case, where we find the equation of straight line passing through two given points. Now, the direction is not given explicitly, but in terms of the points we can get the direction. To find the equation of L passing through two given points, to points P and Q. Okay. So, for example, let me so the P and Q are there, let me draw the straight line. So, this is P, this is Q, and assume that this is the origin, therefore, OP is there. So, OP let me call A, and this is B, OQ. Now, I want to find the, so here now because now in the previous equation, see the vector is simply R minus D. So, if I look at this case, this is equal to R minus D, this can be written as R minus D is equal to alpha times U. Okay. And the same way I can write, now in this case I have taken, so R minus A, because U is the unit vector along the L. So, here the unit vector can be easily found, because P and Q are given, I can find the unit vector. How do you find the unit vector? Alpha times or k times b minus a, the vector. Okay, so here I am calling d, instead of d I am calling the vector a. Okay, so there is no confusion in this. R minus a is equal to alpha times b minus a, because p q is nothing but b minus a. Okay, the vector p q is o q minus o p, the vector b minus vector a divided by, you take the unit vector, so for that just divide by the length of the vector. Okay. So this will be the equation of a straight line passing through p and q, where the small b, the vector small b and the vector small a are the position vectors of the given points p and q. So this is the general equation. So this can be equivalently, I can write this in terms of the b vector also, r minus b, but here this time there should be a r minus b vector, r minus b. Instead of alpha I can put some other constant, let me say k, okay, k times a minus b divided by the length a minus b. So this is also equation of the straight line passing through p and q. Now this I can rewrite, r cap is equal to, I can write this k a bar divided by mod a minus b plus, I can take there is a b bar in the right side, the vector b in the right side, therefore it is 1 minus k times a bar minus a vector a minus vector b into vector b. Now this I can, if I set, I can easily I can write t times a plus 1 minus t times b vector b, where t is equal to, if I am giving the substitution, a by a minus, sorry, k by t is a real number, k by a minus b, vector a minus vector b, the modulus. Then with that notation it is simply we can write r is r, the vector r is equal to, the equation of the straight line simply as t a plus 1 minus t b, okay, or simply or equivalently also I can write r is equal to simply let us say alpha times a plus beta times b, where alpha plus beta equal to 1. So this is the equation of a straight line. So the general equation of the line is r, vector r is equal to, I can rewrite it again in a simpler way, that is b vector b plus k times or t times, since I have introduced the notation t, t is a real number, t is varying from minus infinity to plus infinity, t is a bar minus b bar, the vector a minus vector b. So this is the equation of the line. So to illustrate this, let me take this example. Let us take 2 points p and q. P is let us say 9 3 minus 2 and q is 4 5 1 minus 1. Then in that case I want to find the equation of the line passing through to given these points p and q, and then so immediately I can derive from this what is the equation. You could find the equation. The problem is find the equation of the line. Find the equation of the line passing through PQ. P and Q. So we know the vector A. The vector A is the OP, that is 9i plus 3j minus 2k. Similarly, here we have for the point Q. Now the equation is, or the required equation is, the vector R is equal to A bar, or I can write B bar. So this is our PQ. So, this is B, this is A. So, the vector B, that is 4i plus 5j minus k plus t times the vector A minus B, which is equal to A minus B is five I minus 2j minus k. Now, so this is the equation for every value of t, we have the point on the line PQ. Okay. So, this is the equation of the line. Similarly, I give one more simple example. If I have a point P which is equal to 9 1 2 and I want to find the equation of the line passing through this P parallel to, so find the equation of the line through P and parallel to the vector 1 1 1. Okay. So, simply we write R is equal to, so the equation will be, the required equation will be 9i plus, because we know that it is passing through P parallel, therefore, the direction cosine is given. Okay. So, our second form, okay, R equal to D plus alpha u, therefore, 9i plus j plus 2k plus k times the vector, that is I plus j plus k. I need not divide by the length of this vector, I do not need to find a unit vector because the k will be taken care, k is just a constant. So, this is for every value of k and hence this is the equation of a straight line that passing through P which is parallel to the point 1 1 1. Okay. Finally, with our knowledge on vector addition, let us write the equation for a plane, and for plane we need to represent a plane we need 3 information. So, let us do this in 3 cases. Okay. So, vector equation of a plane. Okay. The case 1, that is, let us assume that we are interested in finding the equation of a plane passing through the origin, and parallel to given vectors A and B. Okay. So, these are the 2 information we have, and for that the equation, for that what we do is, let us we can, without loss of generality, let us say this is the origin, and without loss of generality we can assume that these are the vectors A and B. Since A and B are free vectors, we can see that A and B are starting from the origin O, and now if you take any point on the plane, I can just extend this vector and then I can form a parallelogram like this. Let us say this is the point P. So, now this is the point, now it is a parallelogram. Now, remember this point P, the vectors A and B all are lying on the same plane. Now, if I look at this P, the position vector of P, then let us call it by R, then R is simply nothing but OP, okay, which is equal to, let us say this point as B, then it is simply OA plus OB. Okay. And this is simply nothing. So, the OA will be some alpha times, it is not exactly equal to the modulus of A, therefore, it is alpha times of the vector A. Similarly, the B also, OB also will be beta times the vector B. Okay. So, now this is the equation, now we have got the equation, R is equal to alpha A plus beta b, okay, where alpha and beta are some scalars. So, this is the equation of the plane passing through the origin parallel to the given vectors a and b. Now, let us go to the case 2. So, instead of the origin let us give a general point. Okay. So, let us say this is the origin and point C is there, capital C, and let me call this vector as small c, and now let us take some point P. Now, if I look at this OP for the point P on the plane, now I want to consider the given things are like this. C is the instead of origin, P is the passing through, we have to find the equation of the plane passing through the point C and parallel to vectors A and B. Okay. Then the equation of the plane can be, now if I take now R, then now remember the point C and the point P are lying on the same plane. Now, if I call the position vector as R, then R is simply it is OC plus CP. By the vector addition it is OC plus CP, and OC is the vector C and CP is alpha times, or by the previous case it is simply alpha times A plus beta times B. Okay. So, this will be the equation of that plane. Therefore, that is R is equal to the equation of the plane passing through the point C and parallel to the vectors A and B is this. Similarly, I just give it as an exercise for you, the case 3. What is the equation of the plane passing through 3 given points A, B, C? Okay. A, B, C. Now, this is the origin and we can call this vector A, vector B, and this is vector C. Okay. So, what will be the equation of the plane passing through A, B and C? Now, just I wanted to use this case 2 to find the equation of the check the following. The equation of the plane is, the required plane is R is equal to alpha times A, okay, and beta times plus beta times B plus gamma times C, where gamma is equal to 1 minus alpha minus beta. So, because of that, so this is the, so you can simply you can use the case 2 and derive that the equation of the plane will be this, and hence we can see I can shortly I can write this as R is equal to alpha A plus beta B plus gamma C, where alpha plus beta plus gamma equal to 1. Okay. So, this is the equation of the plane passing through the given points A, B and C. In this lecture you can just see what all we have seen. Number 1, we have just to recall the definition of vectors and how the vector addition and algebra of vectors are done, and also we have seen how it is easier to represent a vector if I know the position vector, that is if we introduce a coordinate system. Okay. And with that we have introduced also the notion of direction cosines and direction ratios, and then we have seen how to represent a point that divides a given vector PQ that divides in the ratio L and M. So, how to represent that new point, and so similarly as a particular case how to represent the midpoint of any given vector. Okay. Once we have after we have done all that, we have also introduced the equation, how to represent an equation of a vector equation of a line. Thanks for watching.